Okay, so this is not relevant to you. It's okay. Completely okay. So this is not relevant to you, but again, just for my information, when it was a mistake. Yeah, in fact, if you look at the limit, it's there. Because last time we set up. Okay. So for you, it's not applicable, it seems. So your semester is going to end on. Yours is 17B EXP, right? Okay. Take to 6. What is it? Okay. Yeah. Your one is actually, your submissions are on, actually, your semester end is on 19th July. And actually, 26th July. Isn't it? So that's your, so that's why now we need to arrange some extra classes because actually now the issue is we had to, due to different reasons, we could not do certain lectures. So we have another 1, 2, 3, 4, 5, 6, 7, around 7, 8 lectures we have to conduct, right? But we have 2 weeks. So we have to arrange some online lectures, right? The weekday evenings, maybe from 7:30 to 10:30, right? So probably I will discuss with the management and inform you. So probably this Thursday or Friday, we'll have an additional session. But we might not be able to complete the syllabus. Syllabus they complete an amount of time. So therefore, we have another 7, 8 sessions to complete. At least 7 straight. But we have limited time. We have limited time. Therefore, we might need to have a means of how to manage our time. So the best thing what we can do is we can arrange some online lectures. Some online lectures for the lectures that we were unable to do. So we have to arrange, I think, about 3, 4 online lectures. Then we'll be able to manage to finish the syllabus. So and we can complete all this. Right. So I think some online students are also there. Some students are joining online. Okay, we can see that there are 1, 2, 3 students joining online. I hope you can see me as well as you can hear me as well, right? Online students. Yeah, hope it's fine, right? Okay, and the thing is also recorded. So, however, your semester is going to end by 27th of July. So, therefore, we have to expedite the things, and we have to see how we additional lectures. The additional lectures, how to organize these. Right. No problem. Please come. Marathon shoot forward together. Get the piece. Okay. That's last week. Last week is last. Okay. Okay. So today we'll repeat at the beginning. We'll see what we did up to now. What we did up to now, and then we can decide what we have to do in the future as well. So up to now, what we discussed. Sometimes that we started with descriptive analysis. Why did we do descriptive analysis? I have a descriptive analysis. to describe the sample. So we use different techniques to describe the sample as frequency analysis, then what else? Measures of central tendency, measures of dispersion, measures of distribution, and even measures of location as well as graphical analysis we discussed how to do that. The sole intention was what? To describe the sample. To tell about the sample, we use these techniques and we use that to explain. Then we navigated into, after that, we navigated into different analytical techniques that's called correlation. So why did we do a correlation analysis? Why did we do a correlation analysis? To see the association or the relationship between two variables. We did a correlation analysis, isn't it? So while I told descriptive analysis is a univariate analysis, I told you a correlation analysis is what? A bivariate analysis. Why we call it a bivariate analysis? I correlation analysis a bivariate analysis actually. Why do we call it a bivariate? Bivariate analysis. Bivariate analysis. Why? Because use two variables. We look at the association between two variables. So that's why we call it bivariate analysis. Then afterwards, after we discussed correlation analysis, we came into regression analysis. Right? We came into regression analysis. Why did we perform regression analysis? I told you that there are two reasons why someone would perform a regression analysis. What are the two reasons? I have the regression analysis. Look at the note. Please not an exam. Take exam constraints, so we can look at the note. Why did we perform a regression analysis? For two reasons. I mean, not. I told you, I regression analysis. Why do we perform a regression analysis? So, go look at it. Very good. For two people, one is here, E time, isn't it? Now, they do they do what? Do prediction. Now, if you have an example, so the example that you discussed in the class, it goes about the predicting computer programmer salary. Predicting computer programmer salary. We understood how to perform this kind of analysis. This kind of analysis we understood. So there we use two predictors, two independent variables. What are the two independent variables? Can you remember? In our computer programmer's salary example, what were the two independent variables? One was the aptitude part, aptitude test marks. Right? That's 4 as we call it. And then what was the other one? What was the other variable that we considered? That was experience. So we use two predictors to see the prediction or the impact on the dependent variable computer programmer salary. Right? What did we find out? Out of these two predictors, were the two predictors having a significant impact? Yes, indeed, we found it. So we discovered that text computer programmer salary, right? We predict. Did we stop from there? No. So also I told you, while I was teaching regression analysis, there are two kinds of regression as well. One is called simple regression, the other one is called multiple regression. What's the difference? Simple regression and multiple regression, what's the difference? In simple regression, we have one independent variable and one dependent variable. So that's why it's called bivariate regression as well. One independent, one dependent. Then I told you that if you have more than one independent variable, meaning 2 or 3 independent variables, 2 plus, right? 2 plus independent variables. Of course, we'll have always one dependent variable. So in that case, what's that called? A multiple or a multivariate regression analysis. Multiple or multivariate regression analysis. So we discussed that and did we stop from there? No. We proceeded further. And we discussed another important aspect. That's where how to introduce a qualitative nominal variable as an independent variable. Qualitative nominal variable, what an example would be what? Data. Data is qualitative. Can we really measure data? You can't. So that's why we call qualitative nominal variable, categorical variable. I also expect you how to introduce qualitative variables as well, right? As what variables? We have to introduce that to the regression equation in a particular way. Those are called what? Indicator or dummy variable. We discussed one thing. Indicator or dummy variables, right, are the terms that we use to denote, to introduce or to, right, to specify these kind of variables, which are qualitative, nominal variables, quantitative, nominal variables. So we discussed all these things. Indeed, right, the video evidence is also there. You can go and watch the videos in case. This class has that advantage that you can watch the video and you can see what has been done and what is not being done. Right, the recordings are there. So that's an advantage. Did we stop from there? No. Then we ventured into a new dimension in regression analysis. What's that? Testing what? Assumptions of the OLS regression. Ordinary least square regression analysis, we tested the assumptions. How many major assumptions did we take? 6 major assumptions. Now let's try to see what were the 6 assumptions. If you can look at the notes, there's no problem. Right? I give you a separate tutorial on how to check the assumptions and what are the 6 assumptions. So let me ask you one by one and see. Look at the notes, there's no problem. This is not an exam. Right? Make an exam and take it out, notes column. Right. What was the first assumption that we checked? Linearity. We check whether because we are talking about linear regression. Linear regression, we are talking about lines, predictions of lines, right? Using lines, straight lines. So to check linearity assumption, how did you do this? Scatter plots, or we do what? Dot diagram. Dot diagram drawn to see whether there is a linear relationship or not. At that time, we drew 2 scatter plots under this example regression. What were they? So, what was our 2 independent variables and the dependent variable at that time? At that time, we took what? Age and stress to predict what? Life satisfaction. So, we had to draw two scatter plot diagrams. One for age and life satisfaction, the other one for stress and life satisfaction. And we had some conclusions. We saw stress and life satisfaction had a more stronger linear relationship than age and life satisfaction, isn't it? So we noted that test. So that was assumption number 1. So assumption number 2 was what? Assumption number 2? Multi-coordinated. We'll check the multi-coordinated. Multi-coordinated. So let's ask someone, what's multi-coordinated? Look at your notes. Be my guest. Right? Look at your notes. What's multi-coordinated? Very good. Give the correct start. What multi-coordinated? Oh yes, very good. Multi-coordinated means independent variable study and unnecessarily high for unnecessary. Might have correlation, but we need to know. And we don't need to see the independent variable study high unnecessarily high correlation. But you know, that's important. That's more one. You check multi-coordinated. You use 2 cases. One are the one square with or what relationship. The calculation that we have 4 days. And we have if the 4 days is less than what? 0.8. If the 4 days is less than 0.8, what? Do the right. Why? If it is less than 0.8, will it do the right? It's good. Because we have less than 0.8. That's now what? Result number one. To check the what is equal. What was result number two? Here, it is the react pattern. Right? What can I do here? React pattern, sorry. What here? What here? Look at it. That cannot be applied in the pocket. You cannot come in directly. So, here value is variance effective factor. It is impact on fluid, right? So, we expect that the VI value to be less than what? To say that there is no one quantity. You know what I mean? The VI value to be less than what? So in that case, if both tests indicated, then there is no quantities. Age and stress and no significant. As well as the real values equal in 10. In fact, it was less than 5. Because the higher part of the product, right? So you should have taken down those things. At least take down notes. You have to take down notes and you have to correlate, right? Let's get it done. Okay. So that was the second lesson. Linearity and multiplication. What was the third lesson? What was the third lesson? Autopoly. Then हम autopoly लिखेंगे what's autopoly? Lack of significance. So what? Too much correlation between the observations. The observations are now identical. Independence is not so. The observations are highly correlated with each other. You know, the observations will come from independent. That is independent from other observations. If it's not, then it has autopoly. Right? To check autocorrelation, what test did we do? Derwin-Watson test confirmed. Ideally, the Derwin-Watson value should have been passed. What would have been? 2. We told that, yes, very good. So we told that if the Derwin-Watson value is above or below certain values, it's a problem. What's the value? Below 1 or above 3 is it Derwin-Watson has an issue. Autocorrelation issue might be there. So we discussed that as well and we established that as well, right? That's the third assumption we checked. Then it is not from there, no. We proceeded further to check the next three assumptions. What was the fourth assumption? Huh? No outliers. Right? Now let's see what are outliers. What are outliers? Outliers are what? Extremely large or extremely small value. Right? That's what outliers are. Do we need to see outliers in our data set? Data set outliers no. We don't want any outliers in our data set because it steals the result. There are outliers, it should large or small values. It gives undesirable results in prediction and steals the results. So therefore, we have to check for outliers. Right? To check outliers, what was the test that we performed? What was the test that we performed? Fuchs test. Right? Fuchs test. So I got to that around lunchtime. So it was Fuchs test that we used to check the outline. It's nothing to do with cooking or food, but there's a person say, okay, about nutrition. We understood, right? To say that there are no outliers, the Fuchs test value should be less than or above 1. Less than 1. Very good. It has to be less than 1. The Cook's distance has to be less than 1. If this is less than 1, then it's conditional. How about our example? Last difference. Did it have any Cook's distance above 1? No. In any of the examples we tested, the Cook's distance value was not above 1. In fact, for the age, stress, and life satisfaction example, the Cook's distance was I think around 0.34 or something very small. Small level. So therefore, there was no issue related to Cook's distance. Right? That was about Cook's distance. Then we came into and another assumption that we check. What's that? Homoscedasticity. That means there is no heteroscedasticity. What's homoscedasticity? Homoscedasticity. The dangerous term. Oh, you are just one. Right? So what's homoscedasticity? It's also doing residuals. First of all, what are residuals? One of them is residuals. Residuals are errors. Right? Errors. So we want to check whether the errors, variance of these errors are constant. Right? Errors constantly give variance. We want to check whether the errors were constant across the board. Right? So that's what we call homoscedasticity. Heteroscedasticity means the issue where the variance of the errors or the residuals are not the same across the board. To check that, what did we do? To check homoscedasticity, what we did? Yes, we drew what? Residual plots. Residual plots. The residual plots, if those dots came as a triangle, then we call it what? There's an issue. But if it is just right, shown here and they're scattered, right, without a particular pattern like a triangle, if it doesn't fall like a triangle, then we call it what? There is no heteroscedasticity. Homoscedasticity assumption is met. To check that, what do we do? Residual plots. Right. So that's what we did for them. Then finally, I'm just reminding you what we did. Before we want to tell what we are doing, you have to know what we did do. Then to check the final assumption. What was the final assumption? Normality of residuals. Normality of residuals. So to check normality of residuals, what did we do? What's the test that we do? We do TP plots. Is it TP plot? To check the normality. And we understood if the observed values fall in that part diagonal, the expected normal line, right? The diagonal that you expected, if those observations align and fall within or align with that diagonal, we say there is no issue. How about our case? Opposite, right? For the age, stress, and the life satisfaction example. What did you see there? Did you see that observed points falling align? That diagonal line, straight line. Yes or no? Yes or no? So we concluded what? That's good. So likewise, we satisfied all 6 assumptions in our equation. Right? I hope you can remember it. And that's where we finished last week. So I took you through the entire things that we discussed. Apart from that, I just explained to you how to open data, how to create a data set in data, how to specify labels for variables, how to specify value labels for variables, how to create variables. We all discussed these things during this session. So we had a lengthy discussion. And today I will teach you much more. Today I will now be test of difference. So please take down the topic, amend the topic, test of difference. Amend the topic, test of difference. Oh, very good, very good. Oh, yes. And also, let me teach you a small technique as well. Thank you very much. Alright. So, there was a question last time that can we, now we are running commands. These are all commands that we run. Now, let me show you. Thank you, Kuta, for reminding. Now, let's take for an example. Let's download status session 3 survey for ED. Go to week number 5 and please download status session 3 survey for ED. Please download that file. Status session, right? 3 or 2, whatever. 3 survey for ED. So that's the file that contains life satisfaction data as well as age stress of 436 employees. Right? Right. So then let's open Stata. So I'm going to go to Stata and I'm going to open it. So I'm going to use Stata now 19BE. I hope it's not expired. Please open it. Okay, so you have opened it. And I'm going to say test for any updates. Yes, check for any updates. You can say okay, but then after that something should come. Don't say okay. It says some updates are there. I'm not interested in that because it will take time to update it. Right. Now let's say I want to open the data set. How am I going to open the data set that I just downloaded? File. Open. And here I have got status session 3 survey for it. Status session 3 survey for ED. I'll say open. Now you can see a command was passed. It opened, the command was passed. You don't need to remember this command, but we are using the menu. So you can say use, and in the command history, that command is also listed. Then afterwards, what did we do? I ask you to, now usually once you download, I ask you to do what? Browse. Browse the contents once you open the file, isn't it? Browse to see whether it's imported properly. So I'm going to now use browse command. That I'm going to type here, browse, and I'm going to hit enter. So it opens the data set. That's called a browse command. Now, how many commands did I pass? How many commands did I pass? 2 commands I passed. I opened the file, that's the use command, then I use the browse command. And also, I could run descriptive statistics. I don't remember what kind of descriptives that we ran. How to run descriptive statistics? There are different ways. Let's say I want for age and maybe life satisfaction variable some statistics. So I want to descriptive statistics. I went to statistics, summaries, tables, and tests. Then other tables, and I went to compact table of summary statistics. And remember, and then I'm going to select maybe 1 or 2 variables out of this. Let's say for age variable. And then let's say I'm going to go for life satisfaction. Stress is there. Life satisfaction, stress. So I just select these variables. I selected this twice. I'm going to delete that. And then I'm going to say the mean value. Then I would also like to see the maximum value, minimum value. Also, I would like to see the median. Then skewness. Just I'm selecting, you select anything that you want, just to show you certain things. Skewness. And I'm going to select kurtosis. Kurtosis. Right, likewise I selected and I just going to press OK. So descriptive statistics are there. Likewise, I'm when I pass commands, you can see the command is given over there. Command is there. The command is given. The command that I pass was called tab step. You don't need to remember that. It's tab step. And also that's listed there. So the history is there. Now next day when you come, you again need to do this. I'm going to teach you how you can save commands. Now that I was learning how to command, how much save command, now that I was learning again, I'm going to teach you. If you want to again run the command that you ran already, then I'm going to teach you a method to do it. That's called the do file. So please take down do file. Do file. D-O-F-I-L-E. Do file. Do file. Right. So how to write this do file, I'll show you. So I'm going to open a PowerPoint. To show you how to, because I'm a little bit unable to use the board because there are some online students. Okay. Do file. Now what's a do file? As the name says, a do file, you can save commands and rerun that later. Together. Because remember, in Stata you get outputs. Now this output is there. It doesn't get saved unless you copy that and paste it somewhere else. And also these commands, once you close Stata, it's gone. Right? These commands are gone once you close Stata. So what I'm going to now teach you is how to save these commands for later use. You can save these commands, not the output. You can save these commands in a do file. In a do file, you can save it. A do file is where you can store your commands that you run. Please take down under do file. In a do file, in a do file, in a do file, in a do file, we could say, in a do file, we could say, in a do file, we could say, data commands, data commands, do file, we could say, data command, do file, we could say data command, and run it, and run it, and run it, and run it, later, and run it, later. Save data command and run them later. And run them later. So how to open a do file? Open the do file and open it. Look at here. So the easiest way is, you can see here, if you go here with a pencil and a notepad, it says what? New do file editor. Can you see that? So go to new do file editor and click once. New do file editor. Right. That's the easiest way. New do file editor. So click that once. notepad के pencil लगे तो click करा. This one now. So it will open a do file editor. So it's a text file, right? A blank text file which says what? Do file editor. Did you open that, everyone? Or it was in the do file editor. Did you open that? Right. So these are text files. Now what you can do is you can copy and paste the commands that you already ran. But first let's copy one by one. So let's say I want to copy this command. This is the first command that's there, isn't it? Use command. So I'm going to copy that, right click, copy. Then I'm going to go to Stata window again. And the next window is do file editor. And I'm going to paste it here. So you can see I pasted this command in the do file editor in the text file. The text file I pasted. So let's say I want to paste the next one. I left some lines and I went back to the Stata main window and I am going to run browse. I'm going to select browse. I'm going to copy that and I'm going to put that also in the do file editor. Right, next I'll go back and I'm going to copy the tabstat command, copy that, and I'm going to paste that again here. So you can see I have stored the 3 commands in a do file editor, which can be run anytime later. So please now save the do file editor. You can see commands in do file are indicated in what color? What color? What color? Blue color. Commands are in blue color. The text is in different other color. On the other hand, you can put remarks also. Later on, if you want, you can have remarks also. I teach you that we will. But this is how you copy and paste the commands you already run, right? Running Stata main window. Then you can save this. Do file, you have to save it separately. These are the data file, these the commands that you ran, which you can save in a separate location. So let's save that. So I will save it. I'll go to file. I'll go to save. Yes, I'm going to save it in my beloved download folder. And I'll give the name. My first 2 commands. Give any name. You want give your own name. No problem. Just give a name and say save. Did you save that? Yes, you save it. Likewise, even if you have hundreds of commands, you can just save it. Anyone who faced difficult? Anyone who faced difficult? Why? Okay. Why is it? Right. Now, for this what magic? They're going to magic that. Right. Now you come next day. And here now say, no, now say you shut down the computer, then the Stata is not running, right? Okay. So you, let's say you close this all, Stata is not there. Or Stata there. It's not there. Now let's say you want to run again those commands. What were the commands that you ran? Open command, then browse command, as well as tabstat command, descriptive statistics command. Now if you want, you can again click and click. But Stata, right, in Stata do files, you can rerun those commands without any issue. Shall we see how to do that? Right. First open status. Right, as usual. Open any status session, a fresh session. And then Puta, directly go to the do file. Don't open any file. Now, are any files open? No. Go directly to do file editor. Go directly to do file editor. And go to file. Open. And open. Or if you don't want to go that far, you can see here. Open. And go and open the do file you saved. In my download folder, now there are several files. So let me go to my download folder, which was there I saved. Here, it says my first do file command. Right, my first do commands. Open them. Right, so you have the 3 commands. So I'm going to little bit minimize this, not minimize. I'm not going to make it not maximized. Then, now what I could do is now these were run right before. Now I can rerun them immediately. What I do is I'll select all these commands together, or you can run by one. I'll select all, and there's a small sign here. It says execute. So select first the commands. Isela commands select karla. Minna metana execute කියලා තියෙනවා. Can you see an execute button? Run that. So you can see within seconds, all what you did comes back. Right? So all the commands were run within seconds. It's a matter of selecting and running them. The do file. That's how you could save commands in state and rerun that some other time. Anyone who could do that, please raise your hand. Second, verify क्या दूसरा? करा दे. तीसरा, कमांड क्या देव करेंगे? और कमांड क्या दूँ? अभी आ रही है the variable name cannot change. Variable name is same. What the variable one? What the variable one? Understand? Do fine. So we can reuse commands without any issue. කිසිම ප්‍රශ්නයක් නැතුව ආයිත් commands දුවන්න පුළුවන්. Can run it. That's using do file. So now those days I could remember when I had to run. I had about 100 data sets. So I write two commands. And again run. And if you know a little bit of programming, you can rerun again and again the commands. And you can use ChatGPT for that as well to create different kinds of commands for status and rerun. So that's how you can save commands. And then another question was asked, can we save the output? Output can save the back. So now for an example, then බලන්න මේ දිහා බලන්න. හරි දැන් ඒ do file එක එච්චර තමයි. හරි. දැන් බලන්න. දැන් මේ table එකක් මෙතන තියෙනවා. First is table, descriptive statistics table. Let's say I want to save that. Let's see now how to save this table. ඒක ලේසි නෑ. Right? Look at this. How to save a table that was created in Shaker in another place. My recommendation is, right, first copy and paste this to Excel. I don't cut it here, we can say that. Right? First copy and paste a table to Microsoft Excel. Now let's say I want this table in Microsoft Excel. How to get that? Look at here very carefully. මේක හොඳට බලන්න. වෙන විදිහකට කරොත් අවුල් වෙනවා. If you want to copy this table, start from the bottom. එහෙම තමයි මේක වෙන්නේ. Start from here. Start from the bottom and I copy it till the beginning. මොකද මම කරේ? දැන් මේ table එක Excel වල copy කරන්න ඕන නම් යටින් පටන් ගන්න. Select the entire table. Then right click and copy table. Copy නෙවෙයි. You have to select copy table. Or you can, if you want to have as it is, copy as picture. If you want the exact table as it is, its data, you can say copy as picture. But if it is picture, then you cannot edit it. So you can say copy table. And then go to Excel. Open a blank Excel sheet and paste it. See the table comes. Then make the adjustments that you. Right? This is how you copy and paste information from data to some other product. You cannot save this data, but Windows. Data can remove save parameters. You have to copy Excel and put that to Excel or Word file. I recommend putting that in Excel. It is easy to manipulate. Or what you can do is you can copy and paste as a picture. That's why the picture copy there below. Right click, copy as picture, and you can paste it here. Then exactly as it is, it would come. But you cannot edit. But you cannot edit. For the assignment purposes, right? Assignment is more grand. You copy and paste as a peak. For the assignment. I would like to see you wasting your time putting those in Excel and write something in that. So therefore you copy and paste as a peak. That's more than it. For the assignment. Right? What is it? Do you have an answer? Yes, sir. We have an answer. When is the deadline? Right? 27th July. 1 week before that, the individual assignment has to be done. So therefore, work hard. You have an answer. Right? This is how you run. How you would save. So a question was asked, a very valid question was asked. Can you save state commands? Yes. How can you save state commands? In where? Do files. Do files will save command. And you can rerun that any amount of time. The only requirement is the variable names has to be the same. That's the main. Number 2, the second question was asked, how to save the output of state. Can you directly save text file? You have to copy and paste it as a table, or you have to paste it as a text. I hope I addressed that question. For the benefit of all, so 2 questions were asked last time, and then I asked to remind it, and it was reminded. Thank you very much. Not I would have forgotten. So how to rerun command in space? That's how you would rerun command in space. Right. Okay. Okay. So let's go to today's next proceedings. So you can go to the LMS. So please go to the LMS and go to week number 7. Under week number 7, you will see there is a PowerPoint file that's named as Status Session 5, T-Test and ANOVA. Can you see that? Please download. So today we are going to discuss what are these T-Test and what are these ANOVA tests. T-Test and ANOVA. That's what we are going to discuss. So put a major topic, test of difference. So who topic are they? Test of difference. Have a major topic, test of difference. Test of difference. But we are going to see how we can difference. We are going to see how we can difference. Because test of difference. Test of difference. So download and open it. Test of difference. Test of difference. Okay. So suppose now you want to see whether now here in this class we have male students and female students, right? 2 groups. Now let's say I want to see whether males are satisfied with their life or females are satisfied with their life compared. Who are more satisfied? Is it males or females? Males or females? I don't. I need statistics. Unless I have statistics, I cannot check. So we'll do that. Now we have a data set of 436 employees who have both males and females and their life satisfaction. So let's see whether males are satisfied than females or vice versa. So likewise, if you want to compare two groups, you can perform these tests. These are called test of difference. So in order to do the comparisons, you can see in the next slide I have given you. If you want to compare two groups, you can perform, let's say, t-tests. And you can perform t-tests. You can see difference between two groups. Can you see the first bullet point? The first bullet point indicates if you want to compare two groups, you can perform t-tests. T-tests. And there are three kinds of t-tests. What are the kinds? Independent sample t-test, paired sample t-test, as well as one sample. You want to compare two things. Now, for example, males and females, whether they are satisfied with their life. Now, at the end of this semester, you are going to have what? An exam. Yes. So at the end of the exam, you are going to get what? Grades. Then let's say I would see whether the grades for package-based data analysis subject. I want to compare between males and females who have got higher grades on average. Can I do that? Yes, I could do that. And I could see whether there is significant difference between these two groups, males and females. So that's what you do under t-tests. What you do? You compare two groups. But in this world, do you have only two groups? Everything two groups? No. Religions, are there only two religions? No. Right? There are four mainstream religions and different variants of them. So therefore, in case if you have more than two groups, what you have to perform is the one-way analysis. One-way analysis is performed to compare more than two groups. And also I'll teach you what are these four mechanisms. So from today onwards, this is what I'm going to teach. Test of difference. You are trying to see the difference between groups. If it is two groups, what's percentage to perform? T-test. If there are more than two groups, you are going to perform one way and one and right. So let's take now the first one. What's the first group comparison that we are going to? It's called T-test. T-test. Right. So please take down independent sample t-test. That's the major topic. Independent sample t-test. Independent sample t-test. So please take down independent sample t-test. Test of differences. We are going to discuss independent sample t-test. Independent sample t-test. So as the name says, what it does is it compares two groups, two independent groups. Now males, females, I told you in this class we have males and females. Are those two independent groups? Is there a common membership, a person having common membership? Male as well as female? Maybe or maybe not, I don't know. I'm not going to physically verify that. But usually you won't have a common member. These are two independent groups, males and females. Right? I'm an auditor, but I have no physical verification. But you don't have okay. So that's what we call independent sample t-test. In an independent sample t-test, what you do is you compare two independent groups, right? Two independent groups in terms of given characteristics, like life satisfaction, marks, or what. So that's what's given here. what it does, so I'm going to small note. The independent sample t-test compares the mean scores of two groups of a given attribute, like marks, satisfaction, or again, happiness. Likewise, you can take a given attribute and compare these two groups. Right? So that's what you do. Is it clear? You compare two groups. Groups take up compare color in terms of given characteristic attribute, like marks, satisfaction, or whatever other things that you want to know. Right. Let's now take an example. Read this example. What it says. First, let me give some background. Let's say a situation like this. You have a factory, let's say. You have a factory and you have 1,000 employees. Right? But you see that these people are making mistakes. These employees are committing mistakes. So how can you reduce them? How are they going to reduce them? By training them. Right? You can train the employees and you can train the mistakes. So consultant has come and told you that they could train all 1,000 employees for 2 million rupees. 2 million rupees, they are going to train all 1,000 employees, so they will commit less mistakes. How can you know whether it's going to be effective or not? At the end of the time, like once they are trained, how would you be able to know whether it's effective or not? What you can do is, you can ask the consultants to train all 1,000 employees, isn't it? And pay them 2 million, and after that see whether they are effective or not, isn't it? If you are the managers, I don't think this organization would survive for. Now how train ka ඊට පස්සේ බලනවා the effective නැද්ද කියලා. You have to pay 2 million. If I win, I will do something different. I will test the sum. So what I'm going to do is, out of these employees, I'm going to take 9 people randomly, right? 9 people randomly, and I call them the experiment group or SWAT. Right? I'll take 10 people. I'm going to give them a label, a name, and a group name as well. The experiment group or trained group. Experiment group. Then I'll take another 9-10 people and call them S2, and I'll call them the control group. Control group. The experiment group and control. Did I take 1,000? No. I took about 9-10 people. Their characteristics are very similar. These two groups are similar characters. Then what I do is, I give the training to only who? To the experiment. I give the training only to the experiment. Then afterwards, I check their error levels. And I check the error levels of both groups, the trained group and the untrained group. And then what I do is, I compare the level of errors, the number of errors. Then I'll check whether there is significant reduction of errors of the train. Is that more plausible? So I can train maybe 50,000 to do that for their time and effort. And if it is successful, I will go for training 1,000 employees. Is it a good plan? So that's what we do under here. And you can perform an independent sample t-test to check whether the trained group and the untrained group are significantly different from each other. Right. So what we have done is, they have taken these two groups, right? So I told that there are two groups. What's the two group? Experimental group or treatment group. With training, there are 9 people. You don't need to have the exact number because you are comparing the average error values, average mistake values. Then you have the control group. They are without training. They are trained for control purpose. Right. Now what we need to see is whether these two groups are significantly different from each other in terms of what? Errors, mistakes. mistakes are the main groups whether the get then take the level. For that, you can perform an independent sample test because why? These are two independent groups. Can there be common membership? Can there be an employee who is trained as well as untrained? No, you can't. So you have what? An independent, you can perform an independent sample test and you can see whether the number of errors committed by, on average by the trained group is significantly lesser than the untrained group. So that's what you are going to do. To do that, you have to follow 4 steps. You have to always follow these 4 steps. Please check out. Step number 1. Step number 1. Step number 1. You have 4 steps, and that I'm going to repeat this again and again and again. On each example, I'm going to repeat. Step number 1. Step number 2. Establish the null hypothesis. Establish the null hypothesis. Establish the null hypothesis. Establish the null hypothesis. So first of all, you have to understand what's a null hypothesis. But even before that, what's a hypothesis? Now in your research methodology class, you should have understood that what's a hypothesis. Then testable assumption. Not all assumptions are hypotheses. Hypotheses are what? Testable assumption. Now I could establish a hypothesis that tomorrow morning it would rain. I would assume that tomorrow morning it would rain. Can I test it? Yes. I would wait till tomorrow morning and I could see whether it would rain or not. Right? So a testable assumption is what is known as a hypothesis. Then what's a null hypothesis? It says no. The assumption is assuming something no. Now if you apply this to this example, we say what? There is no difference between the trained group and the untrained group in terms of mistakes. Right? There is no difference between the trained group and the untrained group in terms of mistakes. So that's what I have written here. You can read. There is no null hypothesis, H naught, and you will always write the null hypothesis as H naught, colon. I think you know that, how to write a hypothesis. Null hypothesis will be written as H naught, colon. That's what I have written there, H naught, colon. There is no statistically significant difference between trained group, the experimental group, and the untrained group, the control group, in terms of mistakes, average mistakes. So these were some. As a scientist, you should not take any sides. You should see that, you should assume that there is no difference. Right? So that's the first step. First step is you assume that there is no significant difference. Then number 2, establish the decision criteria. Number 2 is to establish the decision criteria. Establish the decision criteria. What's the decision criteria? The decision criteria is very simple. The decision criteria says if the significance value or the p value, I think in correlation regression analysis we discussed about significant value and p values. If the sig value or the p value is less than 0.05, reject the null hypothesis. So that will always be the decision criteria. What? Right? If the sig value, if sig value or let's say the p value is less than 0.05, what you do? You reject the null hypothesis. These are the decision criteria to always elaborate. If less than 0.05, reject the null. If it is not less than 0.05, you are unable to take the null. Less than 0.05, reject the null of I. We take the null. Right? This is step number 2. Now you want to see whether the mistakes are different in terms of what? This trained group and untrained group. Group right? Mistakes are the. So first step was what? Establish a null. So there is no difference. No difference between the trained group and untrained group. Then number 2, you establish a decision criteria. Always remember the decision criteria is if the sig value of the p value is less than 0.05, reject the null. Then step number 3. Step number 3, using data, please take down. Using data. Step number 3, using data. Perform an independent sample test. Using data. Perform an independent sample test. Using data. Perform an independent sample test. Perform an independent sample test. And calculate the sequence. Perform an independent sample test. And calculate the sequence. Within brackets here. Sequence. Sequence value. SID. Sequence value. Within brackets here. Safely. Sequence value is known as sequence value here. Okay. Now, shall we see how to perform an independent sample test using scalar? So, this is where the calculation involves. Now, we have to see what the peak value, the sequence value of the peak value. Right? Shall we see how to do